Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn Newton's universal law of gravitation, basics behind it, and we will solve some questions also. Okay, so let's start the video. So under the topic Newton's universal law of gravitation, let's see the definition. It states that every particle in the universe attracts every other particle with a force whose magnitude, what they are telling, whose magnitude is directly proportional to the product of their masses and inversely proportional to square of the distance between them. Okay, so first I have taken here basically 2 point masses, one mass m1 and then mass m2 separated by distance, let's take r. Okay, these masses are placed in air or vacuum. It may be placed in any other medium also, because later we will see gravitational force does not depend upon the medium. Okay, so what will happen that here both these masses will attract each other. Why they will attract each other? Behind that one basic is there, because each and every system always tries to occupy minimum potential energy. This I will teach you when I will tell you potential energy. Okay, so as of now just remember that here both these masses will attract each other. So m1 will attract towards m2, so this side force will be there. I will write here F1 to force on 1 due to 2. Similarly m2 will also attract m1, so here this will be F21 here. Okay, and remember that here this gravitational force is the non-contact force. M1, M2 need not be in contact, and you know always force always exists in pairs. Okay, so F12 and F21 in a pair, and they are following Newton's third law of motion. Okay, so remember that here first thing, both these forces magnitude wise both will be same. F12 is equal to F21, and here I am writing here F. Okay, next one, remember that here if we talk about here the vector wise, so you can see very well the direction of both of forces are opposite. So I can write here F12 equal to minus of F21, magnitude wise same, but if we write in a vector form we have to put minus sign, because what is there, the directions are opposite here. Okay, after that according to the definition what they are telling, proportional to the product of their masses and inversely proportional to square of the distance. So remember that here both these forces are same F, so we can write here, see, F directly proportional to m1 m2 by r square. So after that when I will remove this proportional sign, one proportionality constant will come, that is called a universal gravitational constant, capital G, and this will become here m1 m2 by r square. Okay, so this is going to be the force, gravitational force here, gravitational force. Kindly see very well the formula is F equal to G m1 m2 by r square. As of now we have taken for the point masses. Okay, after that let's see next one under the note, very important point is there. Kindly see here, this formula is applicable only for spherically symmetric masses or point masses. Okay, so here you can see very well first situation, this is the first situation. In this you can see both are the point masses m1 m2 separated by, let's take r, so that formula will be valid. Okay, here you can see this is the maybe hollow sphere, maybe solid sphere, not a problem, because another point mass m2 is outside of this sphere. So what will happen that here the total mass of this hollow or solid sphere can be concentrated at the center. So here also that previous formula gm1 m2 by r square valid. In this situation also both are the spherical bodies are there. So in this situation also what will happen that here the total mass can be concentrated here. It can be concentrated here, and we can use the formula. So first, second, third, in all the three situations directly we can use the formula gm1 m2 by r square, not at all problem. But if we talk about here this fourth case here, in fourth case you can see very well one point mass small m is there and one rod is there of length L and mass capital M. So in this situation Newton's law of gravitation will not be valid. Why? Because it is valid only for point masses or spherically symmetric bodies here. So in this situation remember that here I will just write here, in this situation it will not be valid here. Okay, You may think like this, like, okay, no, I will use the center of mass concept. Maybe you have studied center of mass also. So you will tell, no, the mass of the rod, I will concentrate here. This is the center of mass. And then I will write this formula, like, see, F equal to G capital M into small m by, this is the mass and this is the center of mass of the rod. This is D. This is L by 2. So I will write here like this here, D plus L by 2 whole square. So if in case you are thinking like this by using the center of mass concept also, I would like to tell you this formula is also wrong. Only this formula you cannot apply in this situation. Remember that here. Then what to do? That I will teach you next one. Okay. Kindly see very well. Now let's see here please. Now this is the very important, especially they used to ask in a JEE and all. Kindly see here. That previous situation we are seeing. See, a particle of mass m is placed at a distance small d from one end of a uniform rod with length capital N and mass capital M, as shown in the figure. Okay. Find the magnitude of gravitational force on the particle due to the rod. Okay. So what will happen that here in this situation? See this. First, what I will do here, you know very well, Newton's law of gravitation is applicable for the 2-point masses. So here already point mass is there. Now what I will do here, in a rod also I will take here very small mass I will take here. Okay, this one I have taken here, the very small mass of the rod. And what is this? This mass is dm. Okay, and let's take here this dm, and this small m is how much distance? The distance is x. Now this is also point mass, this is also point mass. Okay, but now what is dm? Remember that here this rod is the uniform mass distribution. So in this situation I can write here, remember that here, you know very well, linear mass density concept I will use here. See, I am using here, see, this is given here dm by, let's take here this length also, this length I have taken here what? Dx. This very small length I have taken dx. So see here this dm by dx, now mass per unit length will be called here the lambda, or what we can write here m by L. Okay, always valid, uniform mass density here, is it? Now this one I will use here. So now let's see gravitational force df on mass small m due to the elementary mass dm of the rod is how much here? Okay, I have taken here this is capital M. This is the capital M. I have taken D capital M. Is it? See here, D capital M. So what can I write here? The formula. Kindly see here this df I can write here G, then M into mass of the rod, dm by what is the distance between them? Dm and small m, how much distance is there? X square. Okay. After that, let's see here, I will write here gm by x square. What is the value of the dm? You can see from here dm, if you will see dm by dx equal to m by L. Okay, so dm is given by, kindly see here, m by L into dx. What dm is given here? Dm I have written m by L into dx from here, is it? Now this form that is there, you now see here. And what is the direction of the df? You know very well the attractive, so this direction here df. Okay, now see, now we have find out force on mass small m due to very small elementary particle, just like a point mass. But what we want to calculate for the complete rod. So in this situation we have to integration, we have to do the integration, we have to cover mass from here to here. So remember that here, later when I will make here, remember that here the limits will be there. At this situation, see, distance is starting from here. So in this situation x will be how much? This distance here d, one end, and in this situation if I write here, what will be the x value? This is d, this is L, so this will be d plus L. So limits of integration will be x equal to d plus L. Okay, so now kindly see here, force on particle due to rod is given by. Okay, so in next page we will just write here, we will just do here the integration here. Okay, so we can write here this F equal to, hence F equal to integration of df here. Where to where we have to put the limits? As I have told you very well, we have to put the limits from x equal to d plus L here. Okay, great. Now what we'll do here, we'll put here the value of the df. Okay, so let me see here, the df value is what is here? Can you see here? Gm by x square into m by L into dx. Anyhow, limits are there, Okay, now what will happen that here? What other things are constant that will come outside? So see, g capital M small m by L, and this will become here x to the power minus 2 into dx. Is it? Limits will be there. G capital M small m by L. Now integration of x to the power minus 2 dx will be what here? See, x to the power minus 2 plus 1 by minus 2 plus 1. I have used the formula x to the power n plus 1 by n plus 1 here, is it? And limits, what is this here? D, and this is d plus L. This is also d, and this is d plus L here. D, and here what is this? D plus L. Okay, so now after that we write here, kindly see, G capital M is small m by L, and what this will become here? It will become here x to the power minus 1 by minus 1. So when you will simplify this, we can write here minus 1 by x d to d plus L. Okay, after that what we can write here? Kindly see here. Now f equal to, I have taken minus outside. Now, so see, minus G capital M is small m by L. Okay, and now it will be just like 1 by x. So first we'll put the upper limit. So this will become here 1 by d plus L. Then I will put here the lower limit. Then this will become here d here. Is it? So what we can write here? Kindly see, G capital M is small m by L. Anyhow, minus is there. Minus, no, minus is there. This minus I have taken outside. Correct now? So see, minus is there. Now let's take here the LCM. What will the LCM here? Kindly see, d into d plus L. Now d will go this side. So d minus d plus L. Okay, so let's simplify this. Minus G capital M is small m by L, and here what this is becoming here? Kindly see, d into d plus L. Is it? So this minus will go multiply inside. So d minus L. So here it will left here only minus L. Okay, so what will happen? This L and this L will cancel out. This minus will become plus. So this formula F is coming here, G capital M is small m by d into d plus L. Okay, so this is going to be the formula between the point mass and the rod. The point mass will experience this much force because of the presence of the rod. This is there, because before also I have told you this is the wrong formula. What is the right formula? The right formula is here. This is the right formula. Is it? See, very, very important. Sometimes they will ask directly. Now we are going to see the next one, very important topic. The topic is the law of gravitation in vector form. Important for the 12th also. Their charges will be there. Okay, so see here please. Here I have taken here x-axis, y-axis. One axis outside of the board, that is the z-axis. Here I have not drawn here. Now see, here I have taken one mass m1, yellow color, m2, yellow color, position vector of the first mass r1, position vector of the second mass r2. Okay, now I have drawn here, this is the position vector r1, position vector r2. I am going to connect between the two masses because we have to take distance between two masses, is it? So I have taken the arrow from m2 to m1. Okay, so what will happen that here, this one will be given here, arrow is towards the r1, so I can write here r1 minus r2. What will be this here? R1 minus R2, vector R1 minus vector R2. So I will write here vector R12. Okay, even if you have seen little bit triangle law of vector addition also, you will know very well here, this R2 and this R12 in the same order and R1 in opposite order here. Okay, so even I can write here, see, if I write here, see, R2 and R12 in same order here, please. Same order means addition, so R2 plus R12, and this is the resultant R1. So what we know here, we know very well here, see, R12 equal to R1 minus R2. I have just tell you from the basics point of view here, from the triangle law of vector addition. Okay, now after that, let's see here, this is the R12, vector R12. So what will happen that here, now this M1 will experience force due to M2 in which direction? This direction I will write here F12. Okay, F12, and in this direction, remember that here the unit vector in this direction is what here? I have taken here R12 cap along the direction of R, vector R12 means R12 cap. Similarly, if I write here the force experienced by mass 2 due to the presence of M1, this will be given here F21 here. Okay, and in this situation, I have taken here this direction unit vector, and this is called here, I have taken here R21 cap here. Okay, so this is the basic diagram here. Now let's see here what we are going to write here. See, force experienced by mass M1 due to the presence of mass M2 is given by. Okay, so which force we are talking about here? This one here. So that means F12. So what we can write here, remember that here, this F12 is given by in a vector form G M1 M2 by what is the distance? The distance is the R12. Okay, so see, R12 square, and vector means we have to multiply with the unit vector also. That means what is the unit vector in this direction? R12 cap here. is it? This one we have got here. Let's make it here equation 1. This thing we have written. Okay. Now after that, let's see. Now we are going to talk about this F21. Is it? So see here now. Again, force experienced by mass M2 due to small d, due to the presence of mass M1 is given by. So let's talk about this F21. Okay. So I can write here, kindly see here, this F21 is given by, right here, magnitude is same as it is, G M1 M2 by, here I will write here what here, R21, no? R21 or R12, anything you can write, not a problem because it is a distance, but just for your sake I am writing here R21, and what is the unit vector is there, R21 cap here. Okay. After that, let's write here the next step, see, G M1 M2 by, you know very well whether we see the distance R12 or R21, both are same only. For example, let's take this one length here, this is AB. So what can I read here? I can tell length is the AB or I can tell length is the BA, both are same only. So R21, even I can write here R12 square, also not a problem here. But if you talk about the direction of R12 cap and R21 cap, both in which direction? Opposite direction. That means this R21 cap I can write here minus of R12 cap here. Is it? See here. Now what I am going to do here, this I am just going to simplify this F21. Is it? So we can write here, see, hence this F21 is equal to, see, G M1 M2 by R12 square and minus of R12 cap. No? So this is the R12 cap and minus I have taken here front. Okay. Hence we can write here, see very well here, F21 is equal to minus, and what is this value? If we talk about here, what is this value? GM1 M2 by R12 square into R12 cap. This is the value of F12. Is it? So what can I write here? This one I can write here F12 here. From where? From equation 1. Okay, from 1 I have written here. So what is coming here? Kindly see here. This is coming here. F21 is equal to minus of F12. Is it? And you can see very well, this is the vector law and it is following what here? That means this is a vector form and it is following the Newton's third law here, as I have told you very well, action reaction forces here. Okay. So this is the vector form of the representation, very important. Okay, great. Now let's see. The formula is F equal to G M1 M2 by R square. But what is this capital G? That we should know now, is it? So see here, about that we are going to see universal gravitational constant capital G. Some important points are there. See here, the first point is what here? The value of capital G is same throughout the universe. No? Very simple. Second point, see, value of G does not depend on the nature and size of the bodies. Okay, very nice. Third point is value of G does not depend on the nature of medium between the bodies. That is the important point, because gravitational force does not depend upon the medium. Whether you put two masses in a air or you put same arrangement in a water, oil, anywhere, any places, what will happen that here? The force will be same, because M1, M2 same, R is same, capital G also does not depend upon the medium, is it? So remember that here. Fourth one, see, in SI unit, value of G is, can you remember that this value? 6.67 into 10 power minus 11 Newton meter square per kilogram square. Remember this. And in a CGS unit, value of G is 6.67 into 10 to the power minus 8 9 centimeter square per gram square. Okay, great. Now this one we have covered. 6.1c, dimensional formula of capital G, m power minus 1, l power 3, t power minus 2. How this formula comes here? Even you should know also. From the formula, I can write here G equal to Fr square by m1 m2. You are intelligent, you can get it very well, is it? So what is the G here? We can get here the force, you know very well here. Force dimensional formula mlt minus 2. R is the distance, so we can write here the L square. What is M? Mass. That means here we can write here M into M, M square. When you will simplify this, you will get this dimensional formula very easy. Okay. So remember that here, especially SI unit and dimensional formula should be remembered. Okay. Great. Now let's see the very important part came. Important point about gravitational force. Very important. Sometimes they will ask directly even. So see, the first point, it is always attractive in nature. Later you will see electrostatic force can be attractive also, repulsive also, because charge can be two types, positive, negative. But here remember that gravitational force is always attractive. Okay. Next point, let's see here, as I told you, it is independent of nature of medium between the masses. When the medium will change, the force will not change here. Okay. Third one, let's see, it is central force, as this force acts along the line joining two masses here. Even if we'll take here the previous situations also, you can see very well. Whenever I have drawn here the forces also, you can see here, I can draw here there also, but these are the line joining the two masses. By the pink color, see, along the line only I have drawn the forces. By the same line it should go here. Maybe this line is looking little bit tilted, but it should be in a which line now? Straight line, remember that here. That's why this is which force? This is the central force. Okay, and fourth one, very important, see, it is conservative force. This thing we have learnt in a work energy power also. So see, it is conservative force. Why? Because see, work done by this force is independent of the path. And second point, what is this? Kindly see here, work done by this force in a round trip is a 0, related to work energy and power chapter, conservative and non-conservative forces and all that here. And how many conservative forces are there in our syllabus? Gravitational force, spring force, and in 12th it will be electrostatic force also. But as of now, we are seeing this one, gravitational force. And the last point, see, it is weaker than electromagnetic and nuclear forces. Okay, so all these points should be remembered here. 5 points are there. We'll see further points also. See the 6 points. See here, it is developed in the form of action reaction pair. Hence, this force obeys Newton's third law of motion, as I have told you. Next one, let's see, 7th one. Force developed between any two masses is called gravitational force. Between any two masses, gravitational force. And force between Earth and any body is called force of gravity. Earth or any planet, because planet is very heavy. So one heavy planet is there, 1 point mass is there. That time we will not tell a gravitational force. What will tell here? We will tell here force of gravity. From there only it will come acceleration due to gravity concept. We will see further. Okay. Next, see, 8th point. Gravitational force on a point mass. Gravitational force on a point mass outside a hollow or solid sphere can be calculated by assuming mass of the sphere at the center. Even I have told you also very well. What I have told you here, one hollow sphere is there and here one mass is there. This is, let's take M2 and let's take this is M1. So what I have told you, as this point mass M2 is outside, the total mass can be concentrated where? The total mass can be concentrated at the center. And if the distance between the masses are r, we can write formula Gm1 m1 m2 by r square. Value not a problem. Why? Because this one is present where? Outside. Outside. This m2 is present where? Outside. Remember that here. Next point, see, 9th one. Gravitational force on a point mass inside a hollow sphere is 0 here. Okay, so here, remember that here one basic thing is there. If in case here one hollow sphere is there, its mass is, let's take for example m1. If in case inside this, inside, what is given here? See, inside. So if inside I have kept another point mass. Okay, so remember that here, how much force it will experience? It will experience 0 force here. It will experience 0 force. Why this happens that here? We will learn in acceleration due to gravity, but I will tell you basic. Why? Because the mass is present inside, and if we talk about here gravitational field around this mass m1, because this is the non-contact force and gravitational field is applicable for the non-contact force. So if we talk about here the gravitational field around this mass, so what will happen that here? It will start from infinity and it will just end at the surface here, like this here, na? Radially inward, like this it will come here, like this it will come here. But what will happen that here? Is there any gravitational field inside this hollow sphere? No. So there is the no gravitational field, so the mass m2 will not experience the force. But you can see very well here, because of this m1, the gravitational field, see, if we talk about here, this gravitational field is coming like this here. From all the directions it will come. So this m2 is present in the gravitational field of m1, non-contact force concept. So only it is experiencing the force. But here m2, it is not present in the gravitational field here. So only it is not experiencing the force here. Okay. And here I have drawn just one line. From all the directions it will come radially inward. Okay. So remember that here, all these 9 points. Very, very important. Is it? Great. Now we are going to solve some basic questions and all. See here, the question is, 2 balls of same material, each of radius r, are placed in contact force of gravitation between them is proportional to how much here, okay? And they are telling same material is there, okay? Two balls of same material is there, okay? And identical, both are having same radius, okay? So remember that here, you know very well here, same material means the density will be same, density equal to mass by volume, okay? So what is the mass of each and every sphere? Mass equal to density into volume. And spherical body means what is the volume? You know very well here, 4 by 3 pi r cube. This is going to be our mass here. So this is mass m, this is also mass m, and you can see very well here they are just in contact. This body does not went inside and all that here, okay? So what will happen that here the total mass of the first sphere can be concentrated at the center. Now like here I have drawn separate diagram. Here also can be concentrated at the center. I have drawn the separate diagram, okay? And the distance between them will be how much here? Kindly see, this is r, this is r. Total how much here? It will come here 2r here, is it? So if I write here the formula, no? Which formula will be there? Formula as it is, Newton's law of gravitation. And what this will happen that they will attract each other. Magnitude wise same here, okay? So see here f. So this f is given by, remember that here, gm square by 2r whole square, correct? So now if we talk about here, see here, from here we can write here, see, f is directly proportional to, here what this will come here, wait. So f we can write here g, and what is the value of the m square? Kindly see from here, it will be rho 4 by 3 pi square into r cube square means r to the power 6, and it will come here 4r square, is it? Now you think about this square only, see, this is r square here, this is r to the power 6 is there. Other all things are constant, okay? So what will happen that here, this f will be directly proportional to r to the power 6 by r square. That means f is directly proportional to r to the power 4. Remember that. Which option is correct here? The correct option is here, option D is the answer. F directly proportional to r to the power 4. Important question. Remember that. Okay. Next one, let's see. The question is, force between two objects of equal mass is capital F. If 25% mass of one object is transferred to the other object, then new force is how much here? Okay. So they are telling equal masses are there. First situation I have taken M1, M2, and how much force is there? F is there. No, they are experiencing how much force? F is there. Okay. So in a first situation, I can write here, in a first situation, see, mass is are same. So M1 equal to M2 equal to M. Okay. And how much force will come here? We can write here G M1 M2. That means G M square by R square. This is equation 1 from the first situation. Okay. After that, what will happen that here? The next situation. Next situation, they are telling what? 25% of mass of one object is transferred to the other. So what will happen? Let's take the mass has transferred from M1 to M2. Transferred. Now let's take here. Let's take here. No. So see, let's take transferred from M1 to M2, and then we are getting the new masses. So what is M1 dash here? New mass. 25% is transferred. That means M minus. No? M1 is M only. So M minus 25% of M. 25% of M. What can I write here? M minus 25% means 25 by 100, it will become 1 by 4. So M minus M by 4, it will come here 3M by 4. Is it? And what about the mass on the other body? So this 25% is going from M1 to M2. Is it? So now this will add up here. M plus 25% of M. So what this will become here? See, M plus M by 4, and this will become here, kindly see here, 5M by 4. Is it? Now this is the new masses. Now students, after that what will happen that here? Now if I calculate here the new force here. So new force, let's take F dash. Now they are not telling anything about the distances. That means they are kept a certain distance apart. Here also R, here also R. Okay, and the force is now F dash. So what will be F dash? Kindly see here G. And the masses, what is this? 3M by 4 and 5M by 4. 3M by 4. And here how much is there? 5M by 4, and distance between them R square. Is it? So 5 into 3, 15, 4 into 4, 16. So we can write here, see, 15 by 16 GM square by R square. But what is GM square by R square? F. Is it? That means we can write here very easily, this F dash is equal to 15F by 16. What is coming here? 15F by 16 here. The correct option is here. Option C is the answer here. Is it? Great. Okay. Now let's see very basic question. This is also, kindly see here. two particles each of equal mass m separated by distance d move along a circle under the action of their mutual gravitational attraction. The speed of each particle is how much here? Okay, so remember the keyword is here, they are moving in a which path? Circular path. And whenever any particle is moving in a circular path, which force is required? Centripetal force is required. Okay, so here I have taken here, let's take here two particles are there, this is mass m, and here also mass m is there, and they are separated by how much distance? D distance here. Okay, so this total distance I am telling here, this total distance how much here? D. Okay, and radius, this is the center, so this is the r, this is r. So what is happening that here between them, which kind of forces will act here? Anyhow attractive force will be there, is it? So I can write here the direction of the force here. This I am telling here that this is the gravitational force Fg, here also gravitational force Fg, is it? And if we talk about here the relation between r and d, so I can tell very well, see, this 2 are equal to d, is it? So what will happen that here in this situation, as the particle is moving in a circular path, that means this gravitational force acting towards the center will act as centripetal force. Centripetal force is not any new force. What is this? Any force can act as a centripetal force, maybe gravitational force, electrostatic force, magnetic force, friction, anything. So what will happen that here this gravitational force will act as a which force? Centripetal force here. Okay, so for circular motion of particles, okay, this centripetal force will be provided by this one here, this gravitational force. So what is the centripetal force formula? Let's take, I have taken only this mass small m. So m speed is v along the tangent, because instantaneous speed, by r is equal to gravitational force formula g m into m. See this m, this m. Distance between them how much here? Kindly see very well here, this r, total how much here? 2r square, 2r whole square, that means this will become here what? 4r square. Now we will cancel the things and all, this m cancel, from this r is cancelled, is it? So from here I can write here this v square I can write, okay, or okay, this v square is equal to what this will become here? Kindly see here, this is the gm by 4r. What is coming here? gm by 4r, or I can write here this v equal to square root of gm by 4r. But you know very well what is the relation between r and d? 2r equal to d. So this 4r I can write here root gm by 4r, means I can write here the 2d. What I can write here, students? 2d here. Okay, so remember that here these things are here. I will just put here into the box here. This is the formula. With this speed, the particles will move in a circular path, and very important, this gravitational force will act as a centripetal force. Remember that here. And now we'll see here the last question. The question is, see, a mass capital M is split into two parts and then separated by a certain distance. The ratio of these masses is how much? So that gravitational force between them is a maximum. Very, very important for 12th point of view also. Okay, so we have one mass capital M, we have separated into two parts here. Okay, so first thing, very easy here, let's take first mass M1 is how much here? X. Okay, then what will be the M2? Because total mass is M is going to separate into two parts, is it? So if M1 is X, what is M2? We can write here M minus X, is it? And they are separated by how much distance? R distance. Anyhow, attractive force will be there, central force along the line joining the masses. So F is there, is it? So now if I write here the gravitational force, what is the gravitational force? F equal to, I can write here C, G, is it? And product of the masses M1, M2, that means X into M minus X by R square here, is it? Now after that, what will happen that here? Just multiply them inside. So see here, G by R square, X will go inside. So this will become here Mx minus X square. Okay. Now after that, what will remember that here? I will teach you for maxima minima concept. Okay. For maxima. Here they are telling maxima, na? So we'll write here. If in the question they told maxima, maximum will be applicable. If they are telling in a minima, minimum will be applicable, because double derivative, if you know, double derivative will set according to that. Okay, so for the maxima, what will happen that here, this df by dx will be how much here? 0. Why I am doing here df by dx? Because this x is the variable. X can be anything. Like if x is m by 3, this have to be how much? 2m by 3. If x is, let's take m by 4, this have to be 3m by 4. So x is the variable. Okay. So for maximum force, what will happen that here? This df by dx should be how much here? 0. Remember that here. Okay. So what I am going to do here, I am going to calculate here the df by dx from this here. So see here, this df by dx I can write here. Can you see this g by r square is constant from here, and I will write here d by dx of mx minus x square. Okay. And from here, what I told you, for maximum force, df by dx should be how much here? 0. Okay. So this here, this 0 is equal to g by r square. D by dx of mx, that means m into 1. Okay. D by dx of x square, this will be 2x. Okay. So from here, what we can write here, kindly see very well, we can write here, see 0 equal to, this is the g by r square. G by r square cannot be 0. So what will be 0 here? See here, this m minus 2x will be 0. So from here, what is the value of the x? This x is coming here m by 2. X is coming what here? M by 2. And in the question, what they are asking here? Ratio. But first we'll find out here the individual masses. So what is the first mass? It will become here x, that means m by 2. Second mass, m2. What is coming here? M minus x, that means m minus m by 2. Again, how much here? M by 2. That means what we are understanding? The gravitational force between two masses will be maximum when they are split in such a way their masses are same. M by 2 and m by 2, then only what will happen? The force will be maximum. And if you take the ratio m1 is to m2, how much here? Both will cancel out, so it will come here 1 is to 1. 1 is to 1. But remember that the masses should be same here. Can you see? Very well. Important for 12th. So students, I hope so. This video based upon the universal law of gravitation with questions are very clear to you. Keep studying, keep growing.